Okay, this is lesson 2.1 from comparing and scaling. We're going to talk about the idea of mixing juices, mixing some juice drinks. So we're looking at how to analyze and compare ratios. So we're going to compare orange juice recipes. Let's get started. Orange juice recipes. We have mix A, mix B, mix C, and mix D. Now, to understand this math, you have to kind of understand what we're talking about here. We're talking about mixing orange juice from concentrate. So, as a reminder of what concentrate is, you've probably seen it before. It comes in this little cylinder container. It's very, very potent juice. And so if you drank the juice straight from this, it'd be way, way, way too strong a flavor. Orange juice, not too bad, but if it's like lemonade, probably would not taste good at all. So, the way you mix orange juice is you mix water in with this concentrate to do what's called dilute the flavor. It makes the flavor not as strong. So, we have 4 different mixes. Mix A, 2 cups of concentrate, 3 cups of cold water. Mix B, 5 cups of concentrate, 9 cups of cold water. Mix C, 1 cup of concentrate, 2 cups of cold water. And mix D, 3 cups of concentrate, 5 cups of cold water. So, A, which mix will make the juice that is the most orangey? That is, which recipe will have the most flavor? Now, orangey isn't a word, but it's often used on tests, so you have to know that it's talking about which one has the most flavor. So, to determine that, we figure out which one has the highest percentage of concentrate. To figure that out, we need to make a part to whole fraction. So, mix A, we have 2 cups of concentrate over a total, so 5 total cups. Mix B, 5 cups of concentrate over 14 total. Mix C, 1 cup of concentrate over 3 total cups. Mix D, 3 cups of concentrate over 8 total cups. Now, we can't really compare these yet to figure out which one has the most, so what we can do is turn them all into percentages. Now, we've already done some practice on this, so I'm going to break out a calculator to speed it up a little bit. Mix A, we have 2 over 5 turns into 0.4. which is 40%. Mix B, we have 5 divided by 14 equals 0.357. 0.357, which is 35.7%. So far, mix A is in the lead. Mix C, 1 divided by 3 is 33%. Mix D, 3 over 8, 0.375, which is 37.5%. Our highest percentage is mix A. So, mix A, because it has the highest percent of concentrate. Question B, which mix will make the juice that is the least orangey? That is, which recipe will have the least flavor? So, we don't have to redo any math, that's just the one that has the lowest percent, which is mix C. So, mix C, because it has the lowest percent of concentrate. Alright, let's move on. Which comparison statement is correct? 5/9 of mix B is concentrate to 5/14 of mix B is concentrate. If we go back to mix B, we know it's 5/14. However, let's figure out why there is a difference. 5/9 or 5, 14? Well, we know that 5 was concentrate, 9 was water, 5 was concentrate, 14 was total. So if we're talking about of mix B, we want the total. This top is part to part, this bottom is part to whole. The total is what we want, the whole is what we want. So that works. D, assuming student gets 1 cup of orange juice and there are 240 students to feed. For each mix, how many batches are needed to make juice for all 240 students? Now, here's where some skills from stretching and shrinking come in. We are going to set up and solve some proportions here. So cross, multiply, and divide. Assuming student gets 1 cup of orange juice. There are 240 students to feed. How many cup batches are needed to make juice for all 240 students? Oh wait, we don't need cross, multiply, and divide yet. That's the bottom. Right now, let's just see. Mix A makes 5 cups of orange juice. We need 240. Simple as 240 divided by 5. 240 divided by 14. 240 divided by 3. And 240 divided by 8. So let's do these divisions real quick. 240 divided by 5 is 48. 48 batches. Now, a batch is just every time you do the recipe, you make a batch. It's like a batch of cookies. 240 divided by 14. 17.14. Well, you can't really make a 0.14 of a batch, so we need to round that to 18. So 17.14 and then 18 batches. Now up next, 240 divided by 3. 80 batches. And lastly, 240 divided by 8. 30 batches. Simple as dividing. Now, for each mix, how much concentrate and how much water is needed to make juice for all 240 students? Here's where the cross, multiply, and divide comes in. So, we're going to need to set up 2 cross, multiply, and divide per problem. It's going to be a bit much. So mix A, let's see, mix A, if we go back, is 2 cups concentrate, 3 cups cold water. So 2 concentrate per 5 total, and 3 water over 5 total. We're making proportions, cross, multiply, and divide. We need to know how much concentrate, x con over 240 total. Bottom, we need x water over 240 total. Didn't leave much room down here, but we'll do it. Let's go ahead and set up all the fractions. So mix B, we know 5 is concentrate over 14 total, and then 9 water over 14 total. Other side of the proportion, same as over here, x con over 240 total, x water over 240 total. Now, mix C, if we go back, is 1 cup concentrate, 2 cups cold water. So 1 con over 3 total, 2 water over 3 total. Other half is going to be the same, x con over 240 total, x water over 240 total. And lastly, mix D is 3 cups concentrate, I believe. Yep, 3 cups concentrate, 5 cups cold water. So 3 con, 8 total, 5 water, 8 total, x con 240 total X water over 240 total. Now, not much room to show your work, so I'm going to get the calculator out once again. Because all it is some simple cross multiply and divide. Now, to show you what I'm cross multiplying and dividing, I'm going to use some green here. Cross multiply, divide. 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 Basically, we're cross multiplying and dividing 8 times. First one, 240 times 2 divided by 5, 96. Concentrate. 240 times 3 divided by 5, 144. Water, and that goes there. I'm going to separate it like that. Mix B. 240 times 5 divided by 14. 85.7. Concentrate. 240 times 9 divided by 14. 154.3. Water. Mix C. 240 times 1 divided by 3. 80. Concentrate. 240 times 2 divided by 3. 160. Water. And lastly, 240 times 3 divided by 8, 90. Concentrate. 240 times 5 divided by 8, 150. Water. And there we have it. That's the water and the concentrate we need to make juice for 240 students. Moving on to practice problems. Compare these 4 mixes for apple juice. Basically, we're doing the same exact thing we did with orange juice, except different juice, different numbers. Mix W, 5 cups concentrate, 8 cups of water. Mix X, 3 cups concentrate, 6 cups cold water. Mix Y, 6 cups concentrate, 9 cups cold water. And mix Z, 3 cups concentrate, 5 cups of cold water. Number 1, which mix would make the most apple juice? Same exact thing as we did before. Cups of concentrate over total cups it makes. Cups of concentrate over total cups it makes. Cups of concentrate over total cups it makes. And cups of concentrate over total cups it makes. Turn these things into percents. 5 divided by 13. 38%. 3 divided by 9. 33%. 6 divided by 15. 40%. And lastly, 3 divided by 8, 37.5%. Which mix would make the most apple juice? Well, that's mix Y because it has 40%. So mix Y because it has the highest percent. Number 2, which mix would make the least apple juice? That would be mix X because it has the lowest What fraction of each recipe is concentrate? Well, we just did that, so I'm going to copy it over. 513. Three over 9. 6 over 15. And lastly, 3 over 8. Nothing else to do there. 4, if you want to make only 1 cup of mixed W, how much concentrate and how much water do you need? So, mixed W is 3 cups concentrate over 9 total. So, 3 con over 9 total. How much concentrate to make 1 cup? 1 times 3 is 3 divided by 9. So 3 divided by 9 does not go into 3. Add a dot 0. Goes in 3 times 27. We got a 3. 3's repeat, so 3's repeat. So 0.33 cups concentrate. Now cold water. 6 cups of water over 9 total. X water over 1 total. 1 times 6 is 6 divided by 9. So 6 divided by 9. 9 does not go into 6. Goes into 60. 6 times, which is 54. Subtract, we get 6. Repeats, so 6 is repeat. So 0.66 cups of water. I'm going to circle those so my answer is clear. Alright, let's go back over the worksheet, make sure we've answered everything completely. Okay, this was lesson 2.1, mixing juices out of comparing and scaling. We want to know how to analyze and compare ratios. So to show that, we are comparing orange juice recipes. Here were our orange juice recipes. We calculated the most orangey and the least orangey. We answered some questions about those mixes, did some cross multiplying and dividing. During the practice problems, we compared mixes of apple juices, compared those mixes, figured out which one's the most appley and least appley, and then answered some questions about those juices. This is the end of lesson 2.1. Up next is lesson 2.2 of comparing and scaling.